All right, so we got to finish and we got to work on, before spring break we left off and we were talking about, the second learning target, I can identify the theories of how the earth has changed, and I understand their importance on developing current theories, which we touched on again in the bell ringer, and we're building on that today. Okay, and then the third learning target we're going to get to and cover today, I can identify the 3 types of plate boundaries and the landforms that are created. That will go along with your game tomorrow with Mrs. Wilson Says. Okay, so a couple of things. Let's review a few things just to cover our bases. As you look at your notes on the right-hand side there, that first box, okay, the first box you filled in, you wrote a sentence at the very bottom of that box. Can somebody read for me the sentence that you wrote on the bottom of that first box? Destiny, what you got?
The oceanic crust is more dense than the continental crust.
All right, oceanic crust is more dense than continental crust. Why? Does anybody remember? Anybody remember? Oceanic. Why do you think oceanic crust is more dense than continental crust? Hunter, why do you think so?
Because whenever we were watching the video or the PowerPoint, it showed like the oceanic crust going underneath the continental crust and going down and then coming back up.
Okay, so anytime something sinks, it tends to be what?
More dense.
More dense, good. Okay, anytime something tends to be less dense, it tends to do what?
Nope.
It does what, Virginia? Rises. Good. Okay. All right. So let's go ahead and then let's look at your convection current. So if you look at that picture that you've drawn, and I see some good pictures drawn in there of convection currents. You've got your core, you've got your red arrows and your blue arrows. Okay. All right. So what do the red arrows represent?
No.
All right, look at your notes, and you should have them labeled pretty good in there. I know you guys are sleepy from spring break, but I need you to wake up. All right, let's look at your red notes. What does the red mean? Peyton, what does the red mean?
Rises.
Okay, why does it rise?
Because it has more heat, so it's more dense.
All right. It rises, has more heat, so it's less dense, okay? And what does the blue represent? Sammy?
Cool air, so it's more dense and it sinks.
Good. It's cool, and it represents that it's more dense, so it sinks. So we've got this what type of motion?
Circular.
Circular motion. Okay, so if we pretend that I am standing at the top here above this current, and this happens to be my plate. Okay, which way am I going to tend to go, or which way is my plate going to move? Okay, am I going to go, and I want everybody to decide, okay, am I going to go towards the door, or am I going to go towards the windows? Which way? Point that direction. Okay, all right. So notice that I'm following this convection current. So if I'm following that convection current, thank you for those of you that are pointing to the door, because that's the way I'm going to go. Okay. Now, if Ashley is standing on this plate over here, okay, which way is she going to go? Point the direction. All right, I want everybody looking up there. You'll notice that she's also going to go towards the door. Okay, so ultimately, you wrote one sentence out to the side. Okay, about convection currents. What sentence did you write in your box? What sentence should be there? Alicia.
Convection currents determine the direction and speed of the plates.
Good. Convection currents determine the speed and the direction that the plates move. Okay? So with that being said, all these plates create relationships with one another, and we know it because of lasers and satellites. Okay, the movement is very, very small. We're talking about some of these plates only move about 1 centimeter a year. Some move up to 12 centimeters a year. But because of lasers and satellites, they send signals to the Earth, and they're able to calculate how far they move. Okay, so because of those relationships, we've got 3 types of plate boundaries. So we're going to fill in your 3 boxes there in your notes. Okay? Your 3 boxes. So we're going to start in that first box. The first plate boundary, number 1, is what we call divergent boundaries. So this is the first part of your 3rd learning target. I can identify the 3 types of plate boundaries. So number 1 is a divergent boundary. You've got those boxes that I've given to you, and I just want you to draw in your arrows. So you'll notice my arrows are going in what direction? Okay? Are they going towards each other or away from each other? Away. They're going opposite. Okay? So go ahead and draw your arrows in. And then I want you to write that keyword just out to the side, just like I'm doing, away. Okay. Have we talked about this movement before? Yeah? Do you remember when I had you guys line up front? Okay. And we were talking about seafloor spreading. Okay. Those new rocks were moving away from each other. Okay, and they were coming up the middle. So what type of landform did we create? What'd you say, Caleb? A mid-ocean ridge. So it creates a mid-ocean ridge. All right, so it's creating a mid-ocean ridge. And so typically, because it happens on the seafloor, your notes, it says it occurs mostly, or it occurs between, you're going to write oceanic and oceanic crust. So it's worded just slightly different than my notes up there. Okay, so it occurs between oceanic and oceanic crust. Okay. And so if we were to take a field trip, if we were to load into Miss Wilson's Magic School Bus, and if we were to take a field trip to a mid-ocean ridge and to a divergent boundary, there are 2 places that I'd like to go. They're not the only 2 examples of divergent boundaries. Okay, but there are 2 examples that you're going to put in your notes. We've got the Red Sea and the Mid-Atlantic Ridge. All right, so 2 examples. Mid-Atlantic Ridge, what ocean do you think that's in? Atlantic. So smart. Figured it out. Okay. The Red Sea, what continent is the Red Sea near? Okay. Okay. Europe and Asia. Okay, if you look up here, and Africa. Okay, if you look up here, here's Africa. Okay, here's Africa. The Red Sea is right in here. Okay, so if we look at the map that I've got on the board, you'll notice the African plate's moving this way, the Arabian plate's moving this way. So if I take my hands and go in that direction, are they moving apart? Are they moving apart? Yes. Are they moving exactly opposite? No, they're not, but they're still moving apart. So in theory, what's happening to the Red Sea? It's getting wider. It's getting bigger. Okay. Now remember, we just said we're talking 1 centimeter, between 1 centimeter and 12 centimeters a year. So is it going to grow huge in 1 year?
No.
No. But it is widening. Okay. And we can see that movement. All right, let's talk about our game, Mrs. Wilson Says. What do you think Mrs. Wilson Says is going to be like? Simon Says. Okay. So you've got to learn some hand motions. And as cheesy and as corny as it sounds, it's going to help you remember and connect these, okay? And I know how competitive you are, so you're going to want to remember. Okay? All right, Mrs. Wilson Says. So if Mrs. Wilson says base position, that's what you have to learn first. Base position is going to be just you standing with your hands together. So I want everybody, Mrs. Wilson Says base position. Put your pencils down for a second. Take a break. Okay? Everybody's got to participate. Come on, Jesse. Okay? Everybody's on the same page. If you feel dumb, we all feel dumb together, okay? All right. So, if Miss Wilson says divergent boundary, what do you think your hands are going to do? Okay. All right, at least you said right off the bat, and I saw it, separate. Okay, and a lot of you took your hands and you moved them apart. Okay, we're going to make it a little bit more fun. Okay, and so when Mrs. Wilson says divergent, what you're going to do is you're going to walk like an Egyptian. Okay, and you just have to say, and you have to at least say it once, you have to say the word what? What's the key word?
Away.
Away. Okay, now some of you are going to want to say away, away, away. You can just say away once. Okay, all right, so Miss Wilson says base position. Okay, Miss Wilson says divergent boundary. I heard like 4 of you say away. Miss Wilson says divergent boundary.
Away, no.
Wait, what?
Miss Wilson says divergent boundary.
Oh.
Miss Wilson says base position. All right, these are just 2 of the moves, so you got to be able to remember them, okay? All right, so grab your pencil. Let's continue. We'll come back to Miss Wilson says. Okay? All right, so away is divergent boundary. Our second is the exact opposite. So instead of away, we're going to have together. And so number 2, we're in that middle box at the bottom of your notes. Number 2 is convergent boundaries. Okay? And plates are moving towards one another so you can see your arrows and you can draw your arrows in. And the key phrase I want you to write out to the side, I want you to write come together.
Together.
I want you to write come together. There's a reason for that. Okay? Okay, and you can see there's more notes to write, but we're going to stop right there and we're going to go back to Miss Wilson says right off the bat, because convergent boundaries is a little bit tricky. There's multiple hand motions for convergent boundaries. So if we do Mrs. Wilson says base position, where are you? What are you doing? Okay, your hands are side by side. Okay. What do you think naturally you're going to do if Mrs. Wilson says convergent boundary? Okay, I see a lot of you running your hands together. Okay, what I want you to do is I want you to put the tips of your fingers and just push them together. And there's always a saying. So what you're going to do is you're going to say, and I'm sure you've heard the song. You can either sing it or say it. Okay, and it's completely your choice, but you're going to say, come together. All right, so Miss Wilson says convergent boundaries. That was weak. Miss Wilson says convergent boundaries. Okay, Miss Wilson says divergent boundaries. Okay, Miss Wilson says convergent boundaries. Miss Wilson says base position. Miss Wilson says convergent boundaries. Come together. You never know when I'm going to try to throw you off. Okay? All right, so keep with it. Hands down. Grab your pencil. Now, the thing about convergent boundaries is there's different ways that the plates come together. So they interact a little bit differently, and it all depends on what type of crust we have interacting. What are the 2 types of crust? What are the 2 types of crust? Trevor, what's one of them?
Oceanic.
Oceanic, and somebody help Trevor out. What's the other one? Evan?
Continental.
Continental. Which one's more dense, oceanic or continental? Which one's more dense, class? Oceanic is more dense. Okay, so we got to remember that. So our first type of convergent boundary, if we have 2 pieces of oceanic crust coming together, number 1, oceanic versus oceanic. And you'll see a familiar word up there that I'm putting in a box. Okay. All right, what do you remember about the word subduction? We've talked about it before. We had some subduction happening on the outside of our seafloor spreading. Do you remember what subduction means, Sammy?
Kind of goes, like, needs to go down or go inward.
Okay, it goes down. Okay? So looking at our picture, do you see one going down? Yeah, okay, and you can see it right here. You've got this one going down and under the other. Okay? What kind of things do you see are created in this picture? Okay, I heard Trevor say trench. That's one thing you're going to write in your notes. Creates trenches. What else do you see up there? I see a volcano. I do too. And an island. Those 3 things creates in your notes. Okay, for number 1. Oceanic versus oceanic. Then you've got creates trenches, islands, volcanoes. All right, so this is where we add to Miss Wilson says. Okay, so if Miss Wilson says base position, our hands are side by side. Okay. Miss Wilson says convergent boundary, you do what? Okay, now Miss Wilson might say convergent boundary oceanic versus oceanic, and what do you think you might do? Okay, so I see some of you putting one hand under the other. Okay, what word do you think you might say? What's key? Subduction. Okay, so this is what we're going to do. Miss Wilson, when Miss Wilson says convergent boundary oceanic versus oceanic, we're going to get a little gangster and we're going to go subduction. Got it? Miss Wilson says convergent oceanic versus oceanic. Miss Wilson says divergent boundary. Miss Wilson says convergent boundary. Miss Wilson says convergent oceanic versus oceanic. Okay.
Wait, what do you say again?
Subduction. One goes underneath the other. Okay, some of you are like acting like you're way too cool for this. Remember, we're all on the same page. We're going to have some competition and some fun, and it's going to help you remember your landforms. Okay? It's just like Simon says. So, if Miss Wilson says convergent boundary and you say away, you're out. Okay? All right. So, second type, we're still in that middle box in your notes. Second type of convergent boundary. Number 2, we've got oceanic versus continental. And notice what key word is still up there.
Seduction.
Okay? All right, right here. Okay, so what kind of things do you see in my picture that's being created? What can we put in our notes? Creates what? And we might have some similarities. Michael, what's one thing you see? Okay, so we see this volcanic arc. There's one thing, and I see one more thing that's created. Olivia? Trench. Good. Okay, so if Miss Wilson says convergent, oceanic versus continental, what do you think you're going to do?
Same thing.
Same thing, okay? It's still subduction. All right, so Miss Wilson says base position. Okay, Miss Wilson says divergent. Okay, Miss Wilson says convergent. Okay, Miss Wilson says convergent oceanic versus continental. Miss Wilson says convergent oceanic versus oceanic. Okay, all right. We have one last type of convergent boundary. So we're still in that middle box. We've done oceanic versus continental. So what's our last one going to be? Continental versus continental. Good, you guys are with me. All right, so number 3 in that middle box. Still in the middle box. Notice we don't have subduction anymore. What do we have? Collision. Okay. All right, what things are created? I see 2 things that are created. Leslie, what's one? Mountain range. Okay, or mountains is fine. Okay, and then what's the other thing you see up there, Michael? High plateau, or plateau works just fine. Okay, so we've got this battle of density happening, and they're the same density, so mountains are created. Okay, so I see some of you already making some guesses as to what Mrs. Wilson says, what the movement would be. Okay, all right, so collision. All right, so some of you, and I saw Trevor doing this, and I just saw Leslie doing this. Okay, what we're going to do is we're going to go up. We've got these mountains, and so you're going to say, moving on up. Okay, so Mrs. Wilson says convergent boundary. Come together. Miss Wilson says convergent continental versus continental. Oh, I got you. Moving on up. Miss Wilson says convergent continental versus oceanic. Miss Wilson says convergent continental versus continental? All right. So I'm adding to it. We've got one more. All right. Our last box, or your last box, number 3. Okay. Number 3 is transform. Okay. Transform boundary, we also call them strike slip faults. And go ahead and also draw your arrows in there. And I will say this, sometimes there are plates that might move in the same direction. One might move faster than the other. And so you'll have the same type of interaction with them.
Do you have to write them both?
You don't need to write them both, just as long as you recognize. This is the main one that's up there. Okay. Key phrase that I want you to write out to the side. Oops, I hit the wrong button here. Okay. Is slide.
Do we have a key one for the second box?
Yes, come together. It was okay. All right, so the key with this is no crust is formed. So nothing new is created with a transform boundary. Also, along with that, no crust is formed, but no crust is destroyed either. So that first bullet underneath your pictures there, no crust is formed, no crust is destroyed.
Are these 3 going to be the topics for
Yeah.
Okay. All right. And so what happens, nothing's created, nothing's destroyed. But what happens, and I already saw a couple of you with your hands, you're doing this, and what happens when you rub your hands together is you kind of snag. So what do you think is going to happen? There's lots of friction, and ultimately what phenomenon is probably going to happen? What, Trevor? Earthquakes. So we've got lots and lots of earthquakes. Okay? Lots and lots of earthquakes. All right, so our example, if we were to take Mrs. Wilson's magic school bus to a transform boundary, we could actually stay in the United States for this. Okay, where are we going to go, Caleb? California. Anybody know what it's called?
San Francisco.
We might go to San Francisco, but that's not what it's called. What fault is it? There's a movie coming out with The Rock that's called this. That is about it. It's sand something.
Sandstone. Sandberg. Sandman.
All right, look up here. It's California, the San Andreas Fault. There's your example. Okay, and so I believe the movie is called San Andreas. Okay, I don't know if fault's in there or not. I saw a preview for it the last time I was there. I would be interested to see it, to see their take on this. I don't know when it comes out. Okay. It's about the San Andreas Fault. So let's look at our picture up there. So when we look at our direction the plates are moving, you'll notice we've got one moving this way and we've got one moving that way. And so the theory is, and a lot of you have heard the theory, that what's going to happen to California?
It'll be underwater.
Okay. Some people say that it's going to be underwater. Others say that it's going to break off and become its own island. Okay, because of this movement. So the movie itself is about what happens to California as this fault breaks and moves. Okay? Yes? Lots and lots of earthquakes. Okay, and that's why earthquakes. Now, do we have earthquakes in Kentucky? Yes, not very often. Okay, and there is a fault line in western Kentucky. I meant to look it up and I forgot. I want to say it's the Madrid, New Madrid fault line. Okay, and so the same movement is happening. And so that's why sometimes in Kentucky there are earthquakes. It's just not as active as the San Andreas Fault. Okay? All right, so Miss Wilson says face position. Okay? Now, if Miss Wilson says transform, I already showed you the hand movements, but you know there has to be a what? There has to be a saying. So we're going to say slide, 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 slide. Okay?
Slide.
And you can say it once.
Yes.
Okay, but you got to say it. All right, so Miss Wilson says face position. We're going to test you. We're going to run you through it. Miss Wilson says convergent oceanic versus continental. Miss Wilson says divergent. Miss Wilson says convergent. Miss Wilson says convergent continental versus continental. Moving on up. Okay. All right. Miss Wilson says transform. Okay. Miss Wilson says convergent continental versus oceanic. All right. So you've got some practice to do before we actually say Miss Wilson says you have homework, and I want you to go ahead and get out a piece of notebook paper. Yes, we're going to play Miss Wilson says. No. Yes. Okay. All right. We will review them tomorrow before the game. Let's talk about your homework. Piece of notebook paper. All right. 3.8 paragraph. We need to discuss it. Okay, now notice, guys. I'm not going to talk over you. Listen, please. You're going to have a couple minutes to get a head start on it. Okay, what do I normally give you when I give you an assign a 3.8 paragraph? Okay, I normally give you an outline, a graphic organizer. I'm not giving you that today. Okay? With that being said, do you have to turn in a chart?
Yes.
No. Okay? The only thing I'm going to collect is a paragraph. I'm testing your ability to set up a 3.8 paragraph. Okay? So what kind of things am I going to make sure are included, or do you want to make sure as you write your paragraph?
Transition words.
Okay, transition words. How many total sentences is it going to be?
8.
Okay, what's the first sentence?
Introduction.
Claim your intro sentence. What's your last sentence?
Conclusion.
Your conclusion. Okay, in the middle you'll have 3 proofs and 3 pieces of evidence. Okay, so your question and what I want you to write at the top of your paper so you remember it. Not only do I want you, and it's in your agenda on the board. Okay, 3.8 paragraph. It says explain the 3 main types of plate boundaries. So write that across the top of your paper. Explain the 3 main types of plate boundaries. Okay, now we talked about lots of different plate boundaries. What do I mean by, and notice I underlined main. So what do I mean by main?